Hello, this is Tyler Beamer, math instructor at Haywood Community College. It's an instructional math video for DMA 040. This video is in regards to Module 4, Section 8, Formulas and Problem Solving. So a formula is an equation that states a known relationship among multiple quantities. We see formulas quite often in different math courses, whether they be geometric formulas describing the relationship between area of figures or perimeter of figures. We see formulas in many scientific contexts, whether you're looking at converting temperature from Celsius to Fahrenheit and vice versa. So formulas are an integral part of our everyday lives. And here are some basic formulas. Area of a rectangle, financial formula, simple interest, perimeter, which is just adding all the sides of a figure. Physics, distance equals rate times time, and volume. So the ones that you'll see in this section are pretty basic, and so we want to be able to use those formulas to solve for unknown quantities and also to rewrite formulas so that they're solved for different variables. Okay. So many of these problems are word problems, so we want to keep in mind the ideas of problem solving that we talked about in the last section, but they also involve some type of formula to solve. So Charles can afford enough fencing to enclose a rectangular garden with a perimeter of 140 feet. If the width of the garden is to be 30 feet, find the length. Okay, so we want to draw ourselves a picture here. Okay. We know that the garden's rectangular. Okay, so that tells us that opposite sides are the same, have the same length. So we know the width is to be 30, so we'll say this side's the width, so that means the opposite side's also 30, since this is a rectangle. We do not know the length, so we're going to label that X. That is our unknown quantity, so since it's a rectangle, we know the other side's also X. So we have values or variables for all four sides of the garden. So now we know that the information tells us that the perimeter of the garden is 140 feet. Well, perimeter is just the distance around a figure. So if we add all four sides together, that gives us the perimeter, and that should equal 140. And that sets up our equation, in which we can now solve for x. So now we want to combine our like terms. So on the left-hand side, the two x's added together to give you 2x. 30 plus 30 gives me 60. So 2x plus 60 equals 140. So now we want to isolate x, use our adding, subtracting inverses. So the opposite of plus 60 is going to be minus 60. So we get 2x equals 80. So then we want to finally use the dividing inverse, divide both sides by 2. So x should be 40. So now we want to check our solution. So that means that both of these sides are 40. So if I add all four of those sides together, then that should give me 140, and it does. So that's one way to check your answer. Okay. Alright, so here's a problem using a formula that is Dolbear's law, which describes the relationship between the rate at which snowy tree crickets chirp and the air temperature. So crickets chirp more when it's warmer outside. Metabolism has sped up. And of course, when it's colder, metabolism slows down. They chirp less. So there's a relationship there in which we can use that to determine either the temperature or the number of chirps per minute. So here is that formula. T is temperature equals 50 plus N minus 40. N is the number of chirps per minute over 4. So we want to find the number of chirps if the temperature is 65 degrees. Okay, so let's write our formula for Dolbear's law here. Okay, we know that T is 65, so we're going to replace that. And we're solving for N in this case. Okay, so once again, to solve for N, we want to try to isolate it, use those adding, subtracting inverses first. So we want to minus the 50 from both sides. So we get 15 equals N minus 40 divided by 4. And then do the opposite of the division, which is to multiply both sides by 4. So that gives me 60 equals N minus 40. And so that gets rid of the fraction, and the last step would be to add 40 to both sides. So if it was 65 degrees outside, those crickets would be chirping 100 times a minute. Okay. All right. Here's another geometry example. The perimeter of an equilateral triangle is 9 inches more than the perimeter of a square, and the side of the triangle is 6 inches longer than the side of the square. Find the side of the triangle. Okay, so one thing to know about an equilateral triangle is that all sides are equal. So we're going to draw the triangle. Okay. And we know that the perimeter of the equilateral triangle, so we're going to say PT, perimeter of the equilateral triangle, is 9 inches more than the perimeter of the square, which is PS. Okay. And then here is our square. So we can draw a picture of that. We also know that the side of the triangle is 6 inches longer than the side of the square. And we know nothing about the side of the square, so we're going to make that x. And since it's a square, all 4 sides are equal. So they're all x. Okay, and we know the side of the triangle is 6 inches longer than the side of the square. Well, if the side of the square is x, this would be 6 plus x. And since it's equilateral, all of those sides are the same. So now I have enough information to come up with an expression for both the perimeter of the triangle, which is 6 plus x plus 6 plus x plus 6 plus x, and the perimeter of the square, which is x plus x plus x plus x. So I have 9 plus 4x equals 18 plus 3x, and then I can solve from here. So I'm going to give myself a little bit more room. So use our adding, subtracting inverses. Subtract 3x from both sides. So that gives me the x, and then subtract 9 from both sides. And that gives me x. Now x is the side of the square, so it actually asked me to find the side of the triangle. So the side of the triangle is actually 9 plus 6, since the side of the triangle is 6 inches longer than the side of the square. So this is actually 6 plus 9, or 15. And so that would be the side of the triangle that I'm looking for. Okay. Alright, so those are problems using formulas to solve. Oftentimes it is necessary for us to rewrite formulas. So essentially if a formula is solved for one variable, we want to rewrite that so it's solved for another. Okay. So here's an example of that. This is the formula for converting Celsius to Fahrenheit. Notice this formula is solved for F. Well, it may be good in certain situations for me to, when given temperature in Fahrenheit, be able to quickly solve that for Celsius. So we would want to rewrite this equation so that it's solved for C. So we can do that by using the same solving equation tools that we have been using and learning, same process. So we're trying to solve for C, so I'm just going to circle that. That's what I'm trying to isolate. And so once again, I want to work with adding, subtracting inverses like I normally would. The difference is that I got multiple variables. So I can't subtract 32 from F and get a number answer, so I literally keep those separated. F minus 32. Okay. And then I want to, once again, get rid of this fraction. So I would multiply by the reciprocal, which is 5/9. So I'll multiply both sides by 5/9. And so now this formula would be solved for C. C equals 5/9 times F minus 32. So if I have the temperature in Fahrenheit, I can quickly plug it in here and solve for Celsius. So I'm not going to get a numerical answer. I'm just going to rewrite the equation so that it's solved for a different variable. But notice I use the same process as I would for solving equations. That all remains the same. Alright, here's another example of that. Okay, so 4x minus 5y equals 20. Solve for y, so I'm going to circle that. So I want to move everything from the left side but y. So once again, work with the adding, subtracting inverses first. So negative 5y equals negative 4x plus 20. These are not like terms, so I can't combine them. So I keep them separate. And then finally, I want to get rid of the negative 5, so I divide everything by negative 5. So I'm left with y equals, this is going to be a fraction because they're not going to divide into each other, but a negative divided by a negative is a positive. And I can divide negative 5 into 20, which would give me negative 4. And notice I divide everything by negative 5 to keep that equation balanced. And so now this would be solved for y. And if you take the next module, this is a really important piece to be able to do because you will be using this when we look at graphing linear equations. Okay, so hopefully this gives you a good start. If you have any questions whatsoever, as always, please email those to me or stop by the office. All right, have a great day.